I'm Sophie, you're watching The Science of It, and this week we're talking about pressure! So, let's get going. Have you ever wondered how a straw works? We use them so often, but how does the liquid actually get from the bottom of the bottle to the top of the straw?
First, we need to understand a bit more about how pressure works.
So when you blow up a balloon, you're putting air particles inside the balloon, and each of these particles are exerting a force outwards, making the balloon inflate.
When there are more and more air particles inside the balloon, they exert a higher pressure on the inside. So when you let go, the gas moves from an area of high pressure to low pressure and the balloon inflates.
So there we go.
When you put the straw in a liquid, the water level on the inside and the outside of the straw are about the same. And above the liquid there's air that's going to be about the same pressure both inside and outside the straw.
And as we found out, gases like to move from a high pressure to a low pressure.
When you put your mouth over the straw, you create a seal. Then, as you breathe in, you decrease the amount of air as well as the pressure inside, allowing the higher pressure on the rest of the surface to push the liquid up the straw and into your mouth, since the liquid is really hard to compress. But this only works because you're creating a seal around the top of the straw. If there wasn't one, the air would equalize the pressure, so the liquid couldn't be forced up the straw. So you might have thought that straws work because you're sucking the liquid upwards, but it's actually the atmosphere pushing the liquid up the straw, and this means that the atmospheric pressure limits how high the water will go. At sea level, the air pressure is enough to support a column of water about 30 feet high. And we can prove that pressure can move liquids upwards. You'll need a small glass and a dish full of water. Take some blue tack and put it in the centre of the dish, then stick in some matches. Light the matches, then put the glass over the top. Can you see that? The water level's rising. The flame heats the air particles inside the glass, making the hot air expand as the particles are given more kinetic energy. When the flame goes out, the air in the glass starts to cool, and the air particles begin to lose kinetic energy and move closer together, taking up less space. This creates a partial vacuum, and so a lower pressure inside the glass. But there's also a higher pressure outside the glass pressing down on the water in the dish. The outside air pushes the water into the glass, making the water level rise until the pressure is equal both inside and outside the glass. You might think that the oxygen used in combustion plays a part in making the water level rise, but this effect would be extremely small, so we can see from the experiment that pressure differences really can cause liquids to move upwards.
But would this work if you had a really big straw? Like, really, really long? We've actually tried this with a really big straw. So, let's see how that works. How high is this? How high is this?
I don't know.
Okay, so this is on a roof. I'll find out how high it is later. So we were going to try all of that straw, but we didn't have a roof that was high enough off the ground. So here is over 5.5 meters. So let's try that. So right now the liquid is staying where it is, because I've got my thumb over the top. And I'm gonna let go, and we're gonna see what happens.
You know what's going to happen. When I take my thumb off the straw, air rushes in to equalise the pressure, pushing the liquid downwards.
Thanks for watching. If you've got any suggestions for other videos, just pop them in the comments and I'll see you next time.